Okay, we'll do a short final video on kinetic energy and potential energy against time graphs. Alright, so how do we get kinetic energy against time graph? Realize that in this red section over here, we've looked at velocity against displacement, acceleration against displacement, energy against displacement. Okay, we'll finally have a look at kinetic energy against time. Right, so how to get a kinetic energy against time equation? Right, I can use half mv square again, but instead of substituting v square by this equation, now I sub v square by this equation over here because I want kinetic energy with respect to time. Right, so if I sub v square by this equation, I get x naught square omega square cosine square omega t. Right, my total energy, you should know right now, is when this is maximum, when k is maximum. So that happens when cosine square omega t is 1. Right, so my total energy is just this value over here, this value over here in front of cosine square omega t. Okay, to get PE is total energy minus kinetic energy. Right, you should get once you take out the half m x naught square omega square, you get 1 minus cosine square omega t. That should give you sine square omega t. Right, so this is just mathematical from here to here. Okay, so let's look at some of the interesting things about the KE against time graph. Okay, one of the more important things is this. If I look at a cosine graph, it looks like that. Right, a positive cosine graph, the period is at this position, but my KE is a cosine squared graph. Right, so if I square this graph, what happens? Okay, this point becomes this point. Right, so whatever this value here is, I square it, so I get this value. Okay, 0 stays 0, so 0 stays here. This point, because it's negative amplitude, but when I multiply two negative, I get positive, so this is actually the same value as this position. Right, and here again is 0, and here again is amplitude. Right, the key part of understanding a K against time graph is that where is period in a K against time graph? Okay, you need to know that the period is at this position. It follows the cosine graph. Okay, the period comes from the cosine graph, so when you square this graph, you get this. The period must stay at this position. A very big problem with students is they will choose period at this position, right, which is not correct. Okay, this is half period. Okay, the period should be at this position, because when you look at this graph, you will have a tendency to pick, some students will have a tendency to pick this as where the graph repeats itself. Alright, but that's not the case. The period must come from this graph, right, which is actually your cosine graph. Alright, so just pay attention to that. Period must be on the K against time graph. It looks like 2 reps. Right, so the period is at this position, so just pay attention to that. Okay, how to draw the P graph? Very simple. You just draw a sine graph. Right, maybe I'll just draw in a different color. Okay, you just draw a sine graph. Alright, and you square the sine graph, you get something to this extent. Okay, likewise, if you see the sine graph, the period is also here, this position. Okay, so if you see a potential energy graph, right, this would be, this blue one would be KE. If you see a potential energy graph, the period is still here. Right, it follows the original sine graph. Okay, so that's something to pay attention to for your K against time and P against time graphs.